Dah record belum kamera?
Dah.
Okey. Okay, 1, 2, 3. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. We are from Group 7. My name is Daniel Firdaus bin Lasli. Asal kamera?
My name is Kamaruddin.
My name is
Tak boleh.
Kamera sangkut ah?
Kamera sangkut.
Biar je sangkut eh.
And then kau gelak. Okay, tak apa. Teruskan je terus. Okay. Ready? Ready 1, 2, 3. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. We are from Group 7. My name is Daniel Firdaus bin Lasli.
My name is Kamarul Amin bin Kamaruddin.
My name is Muhammad Amir Amzah bin Mahdi.
Okay, today we want to talk about the DC-DC boost converter. Right. For the introduction, the DC-DC boost converter is a type of converter mode switch. In a much simpler way, this converter operates to step up or lift the voltage input from a DC line to a DC line. In order to maintain its power, the current value is kept constant or lowered. The boost converter circuit consists of an inductor, a condenser, a semiconductor switch, and a diode. Alright, for the methodology, first we start creating the DC-DC boost converter and use the parameters seen in table 1 by using the simulation program Simulink or MATLAB. For the converter switch, select one frequency value and one duty cycle value with the aid of the pulse generator. Record and store the duty cycle signal waveform using the scope block. 3. Attach the voltage measurement block to the load in order to calculate the output voltage. Capture and store the output voltage waveform seen in the scope by using the selected frequency and duty ratio. Identify the ripple of output voltage from the simulation. Verify your measurement findings. Okay, the last one, capture and save the inductive current waveform seen in the scope by using the current measurement block. Measure the minimum and maximum current of the inductor. Verify your measurement findings. Next.
Okay, for the operating of the circuit, first when the voltage source is when the current is go through to the inductor, it will create a magnetic field. The magnetic field create the high voltage spike as the magnetic field collapse. This circuit is taking advantage that every property of an inductor to step up the voltage. The duty cycle generation function is just like a normal automatic on-off switch, just like transistor or MOSFET. When the switch is on, the current, the circuit will become short circuit and will not through the diode and the capacitor. It will through to the switch and the current will connect. When is in off switch, the magnetic field pull up in the inductor and it create a high voltage spike. It will push through the diode and get stored in capacitor, and the capacitor will be in charge condition. Because diode is in a forward bias, it will stop the current to flow backward from capacitor when the switch become on. This will every time the voltage spike from the inductor, this add the voltage to the capacitor, and when the spike will step up the voltage in the capacitor. Next slide. Okay, this is our waveform for the duty circuit plus and the output voltage when we done doing this pre-lab preload boost converter. Next slide. This is the device equation for the each circuit calculation, like switch off condition, switch open, and next steady state operation and ripple factor. Okay.
Okay, this is our simulation and this is value for each component. From our simulation, this is the result that we get from our simulation. For the calculation, for the voltage output, we get 125 volt from the calculation. Voltage ripple 0.5 volt. Minimum current 7.5 ampere and minimum value of current 5 ampere. And for the measure, um, all measure value are almost accurate to the calculate value. There's difference between this because due to tolerance in circuit and other condition. From the waveform we obtain from this experiment, this converter can be used in DC to DC power source. We are able to step up DC power source. In order to preserve its power, its output power will giving the circuit max efficiency. Okay, next for the conclusion.
Okay, for the conclusion, in a nutshell, we are able to accomplish all the goals needed when simulating circuit by performing this mini project. Okay, a gate driver is used when running the DC-DC boost converter to act as an amplifier that accepts low power input and transform high current drives to high power transistor. This will allow the voltage from the circuit to be amplified. Then we need to understand the DC converter concept. Although this circuit makes it simpler to connect a DC line to another DC line, both circuit components play a significant role in ensuring that the circuit retains a constant supply of power or amplify its voltage output and maximizes its performance. The prelab portion of this article will clarify this further. And finally, the DC-DC boost converter can be studied in terms of parameter variation. Although it is true that both components play a significant part, the direction of the circuit is modified by minor change to the surface cycle of all frequency. The voltage output will also be amplified by a lower duty cycle or frequency value, but at a lower value, whereas a higher duty cycle or frequency value will show a higher result. To ensure that we achieve optimum performance from this circuit, we must remember to use this parameter carefully. Okay, that's all from our group 7, and thank you from me and to all my friends. Okay, thank you.
Thank you.
Thank you.